All right. So here we have a sheep brain, which anatomically is identical to a human brain. One big difference is orientation. Human brain is oriented longitudinally so that the spinal cord comes out the inferior aspect of the brain, and the sheep oriented horizontally so the spinal cord comes out of the posterior aspect of the brain. So here on the posterior end, we have the spinal cord coming out. On the anterior end, which will be the tip of the frontal lobe, we have two large fat pads, and those fat pads are going to be the cushions that sit at the orbit of each eyeball. Underneath, in these lighter structures, we see the cranial nerves coming off of the inferior surface of the brain, and covering over the entire cerebral surface and cerebellar surface, we have this thick, white, pearly covering. These are the meninges. What you're seeing here on the outer surface, and there's a little incision here so you can see it lifting up. This is the two outermost layers, the dura mater and the arachnoid mater. And you'll see this big space between the arachnoid mater and the surface of the brain. And then you'll notice that the surface of the brain is covered in this shiny, thin covering, which we'll look at more closely in a second, and that's going to be your pia mater. But this space here in a living brain would be filled with the cerebrospinal fluid. So in order to see anything else, first thing we need to do is cut off the meninges. So we're going to slide scissors into that subarachnoid space, taking care to only cut off the superior surface, and we're just going to cut straight along the sides on either side. We don't want to cut off anything on the inferior aspect because we could pull off some of those delicate structures along the midbrain and brainstem region. The meninges thicken over the through the longitudinal fissure and through the transverse sulcus, separating the cerebrum from the cerebellum, and those form the ligaments, the tentorium cerebri and tentorium cerebelli, falx cerebri, and those are going to be the structures that suspend the brain within the cranial cavity.
Hold this with your tweezers. Just hold it back.
So close the tweezers and pull back.
I feel like I'm going in.
So what's being cut now again is the two outermost layers of the meninges, the dura mater, which is the most superficial, sits just underneath the bones of the skull, and a small space below that called the subdural space, and then the arachnoid mater. And then the large space is the subarachnoid space. Just cut straight back right here. Nope, too far, right here.
Right here?
Yep, and just cut straight. Just cut that off for right now. And do the same thing on the other side. So here you're looking again at the two outermost layers of the meninges, and you can see that they are a structurally intact layer, fairly durable, hard to pull apart. Cut straight on. Don't go to the underside. So again, we're not cutting anything off of the inferior aspect of the brain so that we don't pull off any of those delicate inferior structures. Okay. So now you're seeing the cerebral hemispheres become exposed along with the longitudinal fissure, and we're reaching the transverse fissure between the cerebrum and the cerebellum. So now the ligaments are very hard right here, so we're going to have to come up from the brainstem region and cut through the meninges from the coverings over the brainstem, because the meninges do continue down and cover over the length of the spinal cord. And we're going to make that incision up towards the cerebrum. so now we've reached this transverse fissure, and it's really thick in there, and it's going to be hard. We need to move things apart to get this out of the way a little bit. Hang on. So what you need to do is have one person so grab the brain in two hands.
Two hands.
Nope, hold on. One hand over here. Sorry, trying to direct my son here. And one hand on this end. Hold on. I want him to bend this in half. Sorry, no, hold the brain, hold the whole thing, not just that, not just the immunities, guys.
Squeeze.
Yep. And then lift in the middle. And you'll notice that it comes apart right here. Don't pull too hard, guys. And there's a big space right here. And you need to cut along the edge right there. Inward. On this side. I apologize, I am not a professional videographer. Ouch. Cut along the middle.
This twice.
Pull that back a minute, guys. So if you look in here, you'll see these little fibers being stretched out between the brainstem and the meninges, and those are the cranial nerves as they leave the brainstem region. Can you do the same thing on this?
You want this cut further?
Yeah, well, it's gonna come off. It's gotta come off. So
we're gonna go this side.
yeah.
Sit this side of this, right?
Yeah. And all those little yellow strings that you see again are cranial nerves coming out of the brainstem. Alright, so hold on twice. Alright, so now you should be able to flex the cerebrum down from the cerebellum, or cerebellum down from the cerebrum, and there's a big gap in here. So now
You're off the camera.
we need to take our scissors and go straight down to cut this really strong ligament. So we're going to take our scissors and go straight up and down.
This way.
Lift your hand, point the scissors into that.
This?
Yep. And straight down. And you'll hear this crunching as you actually go through it. It's an extremely thick structure. And again, it's designed to suspend the brain in the cranial cavity so it doesn't bang around against the skull bones.
It's cut. And look how far down.
Right. Once it's cut, you should be able to feel it release and lift the two pieces away and just snip the edges off to expose everything right there. So now we have the entire brain exposed. So you're looking at your right and left cerebral hemispheres with the longitudinal fissure running down the center. If you look at the top of the anterior surface, you can see this line running transversely across the longitudinal fissure, equal on both sides. That is going to be your central sulcus, right and left. So on either side of that, you're going to have your precentral gyrus and your postcentral gyrus. Remember, the central sulcus is the separation between motor controls in the frontal lobe and sensory controls in the parietal, occipital, and temporal lobes. All right, so now, if you look closely at the surface of the brain, you can see the shiny covering over the cerebral hemispheres, over the gyri. And if you pull on it with a pickup, it peels back, kind of like you're peeling a sunburn. But it doesn't come off in a nice big layer like the dura mater and arachnoid mater is. So there we get some of it. This that I'm pulling on right here is the pia mater, the innermost layer, the meninges. And you'll see that it was in direct contact with the cerebral cortex, but not enough that we can, or not far enough away that we can actually separate the pia mater off the brain. So we're going to leave the pia mater in place. Okay. Turning around, looking at the posterior aspect, we see the walnut-shaped cerebellum hanging off the posterior and inferior aspect. Flip it over. Why do you have that light?
Let me flip it twice.
On the inferior aspect, we have the pons, the swelling of the pons visible here, going down into the medulla and then the spinal cord. And if I and pulling out too hard, and happens all the time, you can see how the spinal cord actually just pulled completely apart. But right here, you can right here you can see where it came down and in, and this would be the junction between the medulla and the spinal cord. Underneath here, this ball shape is going to be my pituitary gland. And here's those fat pads of the eye. And if you feel around in here, there should be a big cord-like structure coming back from each fat pad towards the area just in front of the pituitary gland. So with your fingers, feel around in the fat pad and feel for a cord-like structure. So,
Watch out.
So I'll clear that out a little bit.
Yeah, move your hand.
So this is going to be the optic chiasmo, which is where the optic nerve to the right and left eyes come together to share information. So these horn-like extensions out here run into these fat pads. Those are your nerves for your sense of vision to each eyeball. Running here along the inferior aspect of the frontal lobe on each side, your right and left frontal lobe, you have cranial nerve 1, the olfactory nerve for the sense of smell. Now in sheep, olfactory nerve 1, or cranial nerve 1, is a lot larger than it is in humans because they rely on their sense of smell a little bit more than we do. So now we're going to turn the brain back over. You're going to put the brain in your hand with the brain stem and spinal cord facing you. Okay. And you're going to put the other hand on top of the cerebral hemispheres and your thumb across the cerebellum and flex the two apart. And what you're looking for, turn it into the large one. Right. So if I clear some of this debris in here, we see what looks like bare hiney cheeks on a seat. That is the corpora quadrigemina. The two hiney cheeks are the superior colliculi, and the seat underneath is the inferior colliculi. And then if we look right above that in the longitudinal fissure region, we see this little wiggly. Alright, so in between the colliculi in the longitudinal fissure, by going a little bit, there's this little wiggly right here. That is the pineal gland.
Stop, dude.
Alright, so what we're going to do now is try to look at the structures of the cerebrum. We found the longitudinal. You can go ahead and put it on the tray. We found the longitudinal fissure and the central sulcus on each side. The lateral sulcus, a little hard to visualize in the sheep's brains because of the way they are structured, but it's going to be right in this region right here. Okay. So if we carefully pull apart with our fingers the two cerebral hemispheres, without pulling, because again, you don't realize until you're feeling it how squishy and soft brain tissue is. All right, so that's right there. So if you look down here in the longitudinal fissure, the tip of the probe is touching this bright white line. That is the top of the corpus callosum. And as I continue to pull apart further, we're separating the corpus callosum. So now we're just going to go ahead and separate the whole thing. So from tip to tip, following the longitudinal fissure from the tip of the frontal lobe through the spinal cord, we're going to cut the brain in half.
From the front.
Yep, right through that long line all the way out the back. Watch your fingers. Try to make smooth, extended strokes, not short, choppy ones, because short, choppy ones cut up the inside. So we want long, smooth cuts. And all the way through the back.
All the way through the back of what?
Keep going all the way, the whole specimen.
The whole down through here?
Through the cerebrum and medulla and spinal cord. So now you're starting to see some of those deeper structures exposed, and it's looking a lot like the diagrams. And if we were in classes, it looks a lot like the models.
Can I just cut this?
Yep. Oh. Okay. So now that we're looking at that mid-sagittal section of the sheep brain here, I have my cerebral cortex. So we're looking at the left cerebral hemisphere. And this white kind of upside down like you swoosh right here is the corpus callosum. Remember, we only have one of those. We have the fornix on its inferior side. And we have this little membrane right here. And that little membrane is the septum pellucidum, which is going to separate the fluid-filled chambers in the right hemisphere from the left hemisphere. So if I poke through this membrane, I am right within this big cavity right here. And that is going to be my left lateral ventricle. And I have the same thing over here on the right. So this is going to be my right lateral ventricle. Okay. And if I scoop around in here, I should be able to pull up this blood vessel right here. All right. So you can see this kind of gnarly worm looking thing coming out. That is my choroid plexus for this particular ventricle. And the choroid plexus is responsible for producing the cerebrospinal fluid that circulates through the ventricles of the brain. Okay. So underneath my fornix, I come out of the cerebral hemisphere and I'm on top of the diencephalon. And you can see in this rounded area here, I have my thalamus. Coming off the posterior aspect right here, I have my pineal gland of my epithalamus and of my, and it sits just above my corpora quadrigemina. Off the anterior surface, inferior surface, I have my hypothalamus. This is my optic chiasm. Coming down here, I have my pituitary gland. You do not see the infundibulum here, though. Right. Coming out of the diencephalon, I go into my midbrain region. Again, corpora quadrigemina is on the posterior aspect there. I have my pons and my medulla oblongata. Okay. All right. Cool. Harder to see here. Let's look at this side real quick. Alright, so looking closely in right here, you can see this little channel. So here's my corpora quadrigemina and the beginnings of my pons right here. This is my cerebral aqueduct coming down here. And this is going to be my fourth ventricle, filling in this space between the pons and the cerebellum. Now again, around the area of the thalamus is going to be my third ventricle. You do not see that chamber because it's a space between the lobes of the thalamus. Here on my cerebellum, you can see the obvious white matter. Okay, so you can clearly see the tree-like pattern of the white matter of the cerebellum, which is called the arbor vitae. And then here is my medulla oblongata, and you can see this pinch point where it becomes the spinal cord. And if you look carefully down the middle here, you can see the channel that is the central canal of the spinal cord. So there you have your brain structures. The one thing I didn't mention, right here in front of my midbrain, coming off the hypothalamus, this is going to be my mammillary body. In sheep, there's one large mammillary body, unlike in humans where you have the smaller right and left mammillary bodies. Okay, so there you have your sheep brain. So what I'm going to do now, so take a look here. You can see the gray matter on the outside, the arbor vitae white matter on the inside. So I'm going to take a chunk out of the cerebral hemisphere over here.
How big of a chunk do you want?
Just a big cube.
Straight down?
Yep.
You just want the brain, right?
Yep. Well, that's the cerebrum. The whole thing's the brain.
Whatever. Can I grab it, dude?
Alright. So you can grab it with your hands, guys. No question.
Keep it over the tray.
Alright. So what Tobias has in his hand is a piece of the cerebral hemisphere. Try it on the side for me so you can see where it's been cut. And if you look inside that piece, you will see the white matter on the inside and the gray matter on the outside of all the gyri. So this gray matter on the outside of the gyri is the cerebral cortex. And that is where all of your integration function is going to occur. So all of the cerebral control centers, precentral gyrus, prefrontal gyrus, all of your somatosensory cortices, your visual cortices, all of the cerebral control centers come in that little thin gray matter on the outside of the cerebrum. Okay. And there you have your brain dissection. Put it over
Go backwards.
I'm only recording here. One of the considerations with brains, especially in recent years, is the development of concussions and their long-term effects. So those thick meningeal layers are designed to suspend the brain within the cranial cavity, so that as we move around, the brain doesn't bang into the walls of the skull. However, it doesn't stop with sudden stops in momentum, hard blows, and the brain can still impact the walls of the skull. So Tobias is going to go ahead and take his section of brain there and give it a little squeeze. Squeeze it. And you can see how easy it compresses. Go ahead and crush it. And it mushes up with very little pressure. So, and this is a preserved brain whose tissues are slightly more dense than a living brain would be. So imagine how easy it would be for your brain to become damaged with small levels of impact.